Dear students, today we shall see how to find the trigonometric functions of sum or the difference of two angles. Trigonometric functions of sum of two angles or the difference of two angles. Okay. So, before we discuss that formula, let me just consider this. Consider a circle with the center at origin and radius r. Okay. Center at origin and radius r. I will choose a point, say P x comma y on that circle. Let P x y be any point on that circle. Let this angle, the angle XOP, let that angle be theta. I will draw one perpendicular here, call this point as M. Angle MOP is equal to theta. This is R, right? Now, if this point is x comma y, then this distance OM is equal to x and the distance PM is equal to y. Now, from this right angle triangle, we can say that sin theta is equal to y by r and cos theta is equal to x by r, which implies y is equal to r sin theta and x is equal to r cos theta, or that point x comma y can be written as r cos theta comma r sin theta. So, any point on that circle can be written as in the form r cos theta comma r sin theta. That theta will vary from 0 to 360 degree. If you choose the point here, then theta is 0. If you choose a point here, then theta is equal to 90 degree. If I choose it here, theta is 180. If I choose here, 270 degree. In that way, if I vary that theta from 0 to 360 degree, you will get all the points on that circle. Okay. In other words, what I am trying to tell you here is that any point on that circle can be expressed as r cos theta comma r sin theta. Okay. So now this knowledge we need for this for the next derivation. What I am going to do, okay, write the heading as trigonometric functions of sum and difference of two angles. Trigonometric functions of sum and difference of two angles. First, I will derive a formula for the sum of trigonometric functions of sum of two angles, and with the help of that we will obtain all the other formula. Okay. Now, this value we know already, this formula we know. Sin of minus x is equal to minus sin x. Cos of minus x is equal to cos x. This is well known to you. Okay. Now, I will give you another formula, that formula is cos x plus y, that is equal to cos x cos y minus sin x sin y. Cos x plus y is equal to cos x cos y minus sin x sin y. This is a very important derivation. This derivation I will do. From where did I get this formula? That I am going to explain you now. This is a very important derivation from exams point of view. It is a definite question for either for 5 marks or for 6 marks. So, they will ask you prove that cos of x plus y equal to cos x cos y minus sin x sin y, or they might ask you derive a formula to find cos x plus y. Okay, such question may be asked for 5 or 6 marks. Okay, so concentrate here. I will consider a unit circle with the center at origin. Unit circle means a circle whose radius is equal to 1 unit. I am considering a circle with the center at origin and a radius 1, unit circle, radius is 1. This is x axis, y axis. Okay. I will choose a point here such that this angle is x. Okay, that angle is x, and I will choose another point here such that I'll call this point as P1. Let this point be P2. I am choosing a point P1 such that angle XO P1 is X, and another point P2 such that, draw a straight line here, okay, another point P2 such that this angle is Y, that is angle P1 O P2 is equal to Y, and I will choose another point here P3 such that this angle XO P3 is minus Y. This angle I am measuring in the clockwise direction. So from here XO P3, in this way I am measuring, so that is minus Y. Okay. Now I'll call this point as P4. I'll call that point as P4. Okay. Now from this I will write like this: angle P4OP1, P4OP1, that angle is equal to X. Angle P1OP2, this angle is equal to Y. P1OP2, that angle is equal to Y. Then angle P4OP2. Look here, angle P4OP1, this much it is X. Then P1OP2, this much it is Y. Then the total angle P4OP2, the total angle is equal to X plus Y. From here to here, this angle is X, this angle is Y. So the total angle is X plus Y. Okay. Then the angle P4OP3, that angle is equal to minus Y. Okay. Now I would like to write the coordinates of these points. Look at P1. P1, earlier, say just before deriving this formula, I explained, I considered a circle with center at origin and radius R. Then that point x comma y, I said we can write it as r cos theta comma r sin theta, where theta is the angle made by that line with x axis and r is the radius of that circle. This is a unit circle that I am considering. That means it's a circle with the radius 1 unit. So this x coordinate of this point will be equal to, the coordinates of this point will be equal to cos x comma sin x. Cos x comma sin x. So P1 is cos x comma sin x. See, I'll show that again here. See, suppose, okay, for better understanding I'll take this. This is theta, this is r, this point is P, x comma y, this is x axis, this is y axis. This is x, this is y. Cos theta is equal to x by r, sin theta is equal to y by r. Therefore, x is equal to r cos theta and y is equal to r sin theta. So x comma y can be written as r cos theta comma r sin theta. Okay. So now that means this point is expressed as r cos theta, r sin theta. Let us say here you have another point and say this angle is alpha. If that angle is alpha, then this point is represented as r cos alpha comma r sin alpha. If one more point you have here, let us say this total angle is beta. Total angle is beta means this point is represented as r cos beta comma r sin beta. Okay. Now coming to this, here the total angle here P4O P1, that angle is x. So this point is represented as r cos x comma r sin x. R is the radius. But here we are considering a circle with the unit radius. That means a circle with the radius is equal to 1 unit. Therefore, the coordinates of P1 will be cos x comma sin x. Then P2. Look at P2. The total angle P4OP2, that angle is equal to x plus y. The angle made by this line with the positive x axis is x plus y. So the coordinates of this point is r cos x plus y comma r sin x plus y. R is 1, so it will be cos of x plus y comma sin of x plus y. Then P3, this angle we know minus y. Okay, angle made by positive x axis along with the P3, this line and this line, that angle is minus y. Therefore it will be cos of minus y comma sin of minus y. Okay, this angle is minus y since it is measured in this direction, minus y. So cos of minus y comma sin of minus y. What about P4? What is angle? P4 means P4 O P4 I am asking. There the angle is 0, so it will become cos 0 comma sin 0. Cos 0 is 1, sin 0 is 0. So P4, coordinates of P4 will be 1 comma 0. Or you can say this is a circle of radius 1 unit and P4 is a point on x axis. If a point is on x axis, then its y coordinate is 0. Therefore the coordinates of this point is 1 comma 0. P4 is 1 comma 0. Okay, now I will join this P2 P4 and I will also join this P1 with P3. Now you look at the triangles P1 O P3 and P2 O P4. Look at the triangle P1 O P3 and triangle P2 O P4. Okay, I am interested in knowing these two triangles. For those two triangles, you observe that two of those sides are equal. OP1 is equal to OP3, that is the radius, that is equal to OP2, that is equal to OP4. So the two sides of this triangle are equal to the two sides of this triangle. Okay, then another angle is also same. Look at this angle P1 O P3 and angle P2 O P4. They are equal in magnitude. Just observe here. Here this angle is y, P1 O P2 is y. So P1 O P3 is that y plus some small angle here. Then you look at P3 O P4. Sorry, P2 O P4. P2 O P4 is, this angle is y, minus y because it's measured in the anti-clockwise direction, in the clockwise direction, sorry. Magnitude is same. This is y and some small angle here. So these two angles are same. Angle P1 O P3 is equal to angle P2 O P4. So here you have two triangles where two sides of this triangle is equal to the two sides of that triangle, and one angle of this triangle is equal to the other angle of that triangle. Then we can say that these two triangles are congruent. Andre sarvasama. Okay, so two sides of this triangle is equal to two sides of that triangle. One angle of this triangle is equal to one angle of that triangle. Therefore we can say that these two triangles are congruent. When two triangles are congruent, that means then the corresponding sides must be equal, corresponding angles must also be equal. So corresponding sides are equal. Two sides are equal to two sides of this triangle are equal to two sides of that triangle. That means the third side of that triangle must be equal to the third side of that triangle also. Okay, so hence I can say that these two triangles are congruent. Triangle P1 OP3 and triangle P2 OP4, they are congruent. When they are congruent, see, they are congruent because two sides of one triangle is, first triangle is equal to two sides of the second triangle. One angle of the first triangle is equal to one angle of the other triangle. What do you call SAS or SSA rule, right? ಕನ್ನಡದೊಳಗೆ ಬಾಕೋಬಾ ಸಿದ್ಧಾಂತ ಅಂತ ಕರಿತಿದ್ವಿ. ಬಾಹು ಕೋನ ಬಾಹು. ಓಕೆ, ಸೊ ಟೂ ಟ್ರಯಾಂಗಲ್ಸ್, ಈ ಎರಡೂ ತ್ರಿಭುಜಗಳು ಸರ್ವಸಮ ಅಂತ ಕರಿತೀವಿ. Okay, so they are congruent triangles. When they are congruent, the corresponding sides are equal and corresponding angles are also equal. So corresponding sides are equal. I am interested in that. Not enough space, so I have to clean this. So one side I will take. What is that side? I will say P1 P3 is equal to P2 P4. Corresponding sides are equal. This is the one that is opposite to those two angles. So P1 P3, see, already we know OP1 is equal to OP2, OP3 equal to OP4, right? So then the third side must also be equal. P1 P3 is equal to P2 P4. Well, now we have studied the distance formula. Let us say if A x1 y1 and B x2 y2 are any 2 points on a plane, then the distance between them AB is given by root of x1 minus x2 whole square plus y1 minus y2 whole square. This is how we find the distance between the 2 points x1 y1 and x2 y2. This is called distance formula. This formula, you already know that formula. That formula I am going to use here to find the distance between P1 and P3. P1 and P3. You can imagine this as x1 y1, x2 y2. So what do you get? Square root of x1 y1. This is x1 y1. This is x2 y2. So x1 minus x2 whole square cos x minus cos of minus y whole square plus x1 minus x2 whole square plus y1 minus y2 whole square sin x minus sin of minus y whole square. This is P1 P3. Okay, then that is equal to P2 P4. P2 P4, find the distance between these 2 points. That will give you cos of x plus y minus 1 whole square. X1, this is x1 y1, this is x2 y2. Now x1 minus x2 whole square cos of x plus y minus 1 whole square plus y2 minus y1 sin of x plus y minus 0 whole square. Okay, so I will square these two equations. Squaring these two equations, I have to clean the board now because there is not enough space to complete this proof. So first I will square this. I will write one more step before I clean the board. So squaring this equation will give you cos x minus cos y whole square. Observe here, I have written cos of minus y as cos y itself. You know that formula, cos of minus x equal to cos x, cos of minus theta equal to cos theta. So cos of minus y, I have written it as cos y only, plus sin x plus sin y whole square. Sin of minus y is equal to minus sin y. So sin x minus sin of minus y is equal to minus sin y. Minus into minus, it will become plus sin y whole square. It is equal to, I am writing this, here we are squaring this. So this will be cos x plus y minus 1 whole square plus sin square x plus y. Is it visible? Okay, I will write here plus sin square x plus y. Okay, sin x plus y minus 0, that is sin x plus y whole square is there, sin square x plus y. Okay, let me continue here. So LHS you have cos x minus cos y whole square plus sin x plus sin y whole square. On RHS we have cos x plus y minus 1 whole square plus sin square x plus y. Here I will expand this by using a minus b whole square formula. Cos x minus cos y whole square, a minus b whole square, that is a square cos square x plus b square cos square y minus 2ab, that is minus 2 cos x cos y plus sin x plus sin y whole square. So that is a plus b whole square, a square plus b square plus 2ab. So that will be sin square x plus sin square y plus 2 sin x sin y, 2 sin x sin y is equal to, on RHS, what do you have? There cos x plus y minus 1 whole square. There again I am using a plus b, a minus b whole square. A square, that is cos square x plus y, plus b square, that is 1 square, which is 1, minus 2ab, that is minus 2 cos x plus y, plus sin square x plus y. Okay. Now look at this, cos square x plus sin square x, that will give you 1. And after that, look at these two, cos square y plus sin square y, that will also give you 1. Cos square x plus sin square x is 1, and cos square y plus sin square y will give you another 1. That 1 plus 1, it will become 2. Then what do you have here? Minus 2 cos x cos y plus 2 sin x sin y. I will take minus 2 as a common factor between those two. Minus 2 into, now what will remain? Cos x cos y minus sin x sin y. Okay. Between these two terms, I have taken minus 2 as a common factor. So you have cos x cos y minus sin x sin y. That's equal to, look at RHS now, cos square x plus y, look at these two terms, cos square x plus y plus sin square x plus y, that sum is 1, and already you have 1 here. So 1 plus 1, that is 2, minus 2 cos x plus y, minus 2 cos x plus y we have. So this 2 gets cancelled, here 2, that gets cancelled. So then you have minus 2 into cos x cos y minus sin x sin y, that's equal to minus 2 into cos of x minus y. Okay, minus 2 gets cancelled. Then what will remain? Cos x cos y minus sin x sin y is equal to cos, x plus y, it is cos x plus y. That is what we want to prove. So we have derived this formula, cos x plus y is equal to cos x cos y minus sin x sin y. This is a very important derivation, a definite question for your final examination. So if you practice this question, it is sure that 5 marks are there in your pocket. Okay. So I'll explain again. See, initially what did we do? We took one circle, a unit circle with center at origin. We choose one point P1 such that angle x over P1 is x, and we choose say here. Okay. Choose a point here, call this as P1, this angle is x. Okay. And another point here P2 such that this angle is y, then total angle is x plus y. Another point here P3 such that this angle is minus y. Then P1 will be cos x comma sin x, the coordinates of P1 is cos x comma sin x, coordinates of P2 is cos x plus y comma sin x plus y, coordinates of P3 is cos of minus y comma sin of minus y, and coordinates of P4 are 1 comma 0. Then join this P1 P3 and join this P2 P4. These two triangle P1 O P3 and P2 O P4, they are congruent. Okay. If they are congruent, then the corresponding sides must be equal. P1 P3 must be equal to P2 P4. Use distance formula, simplify, you will get the answer. That's it, a definite question. Okay. So with the help of this, we are going to derive a lot of formula that I will do it in the next class. So as far as today's class is concerned, it's a very important derivation. You should remember this derivation. Okay. And of course, along with the derivation, you have to remember this formula also. We'll be using this formula in solving the problems also. Okay. So in the next class, with the help of this, I am going to derive a lot many formula. Okay. Thank you. Bye.